So it doesn't matter what side, but I'm going to put the cations on one side of my table. So I'm going to write them down, and then I will show you my table. I'm going to put the cations on one side, and then the anions on the top, and then make a table. And then there are going to be 4 possibilities. So it's asking for at least 4. There's only 4 that we can give them. So, there we go. Oh, what is going on? That's not what I'm looking for. There we go. Okay, so here's my table. So I just copied down the cations and the anions, and then I'm going to match them up. So I'm going to put magnesium with iodine. I have to put the cation first. That's the rule. So I'm going to put Mg first, and I'm going to put I, and then I have to figure out how many Mgs and how many Is. Well, Mg has a 2+ charge, I has a minus charge. So one way I can show, so I can't write any charges in the formula. That's illegal. But we can use the charges to figure out how many. So we can either say, oh, well, if this is 2+, I need 2 minus charges. So I would need 2 iodines, or I can do the crisscross method. Hello. We can take the 2+ and move it down to here. And then this is just 1. I'm really just moving a 1 down here. I don't write a 1 in the formula, and I'm going to put the 2 here. And then after every time I do this, I need to make sure that it's simplified. So I can't divide the same number out of both of these, so we're good. So this one's simplified. So this would be one of my answers. Okay, I'm just going to go across the top. The next one, I would do Mg and S. So the Mg has to go first because it's a cation. Good. And then sulfur has to go next. And then to show I can show my work somewhere else. I cannot write the charge in the formula. So I have Mg2+ and I have S2-. So I could think about this and say, oh, well, this one's 2+, this one's 2-. They're going to cancel each other out. I don't need to I just need 1 of each, 1 to 1. Or I can bring the 2 down. I need 2 sulfurs for 2 magnesiums, but now I have to simplify. There's a 2 here. I can divide both by 2. So our final answer would be MgS. Okay. All right, so that's my second one. Then I'm going to go down to the next cation, aluminum. So I'm going to put aluminum goes first, and then iodine goes second. And then what would my subscripts be here?
That's
just one aluminum. Good.
And
then 3 iodines. Perfect. Do you guys see that? The iodine has a -1 charge. The aluminum has a 3+ charge. So I'm going to need 3 minus charges to balance the 1 3+ charge. Okay. And then the last thing, what will go in this box?
Al2 and then S3.
Good. S3. Okay. So I can either write it out to show my work, if that's helpful. Al3+ and S2-. I'm going to put the 3 down here and then the 2 here. Make sure that it's simplified. Or you can, you can bring it down there. Or you can say like, oh, this is a 3+, this is a 2- charge. So I need to find the common multiple. So the least common multiple of 3 and 2 is 6. If I times this by 2 and this by 3, then both of them will have 6+ charge, or 6. This will be 6+, this will be 6-, and they'll balance. Okay, questions on that one? So then in the box that Alex gives me, I'm going to write out each of these. I'm going to write this, I'm going to write this, I'm going to write this, I'm going to write this. When I do this problem, I'm going to check, make sure the cation goes first. I'm also going to check, make sure everything is simplified. And make sure you have 4. On the final, there are 40. Yeah, so this would be 1 of 40. 1 of the 40. Like, not with the same values, but like this type is 1 of the 40. Okay, questions for me on this one? You think you could do this on the final?
For the finals, did you give us like specific topics to review?
I will, yes. Usually in about March, so beginning of Q4, I give you a packet, and the packet is like an example final. So it gives you, and it's not, so what I would use the packet for is I would go through the packet and find the topics that match the packet on Alex, because the packet's not going to give you feedback.
Okay.
I have the key for the packet. I just think that's easier. And you're gonna take the final on Alex. So. Okay. Let's go to chapter 9, Ashes and Bases. So this is where you are going to start needing to know the common strong acids and strong bases, and there's like one weak acid and one weak base. I'm looking for alpha here. Oh, so first let's do an activity. Okay, this one. So I'm gonna see if we have groups. I'm gonna give you this little packet of values or compounds, like compounds. And you're gonna, as a group, you're gonna categorize them into 3 groups. I don't think I have enough for everyone to do it by themselves. Will you guys like group together? Okay, I have 2 left. Let's see. What can you guys all go like to that table, and then I'm gonna take part of this. And you might have to. So you can either find a group that has the activity, or you can wait and we can give you the activity in a minute. So you're trying to group them into 3 groups.
And then there's different ones. Right? Like what's scheduled? I mean, ionic is not because of the
Sorry, I have no idea.
but NaCl is ionic. What's I don't know. A base.
So you get to decide, but you should divide them into 3 groups.
So I think we need to find the acids inside.
Okay.
I think so.
We do it start with H. Or this one to N.
Okay, well, let's go with Abraham. Is that like, is that one she got?
Yes.
You guys are
She's from Abraham?
No, we just don't know like the.
Abraham baby.
Oh, did you put on your?
Yeah.
Something like diabetes.
Oh, but I guess.
Diving into that?
Except not all.
My understanding, like, everything was right. I just didn't think that.
Like, what is that?
Like, that's the great, that's the whole.
Oh, you said that's describing.
What else should I talk about? We talked about the advantages and this.
I'm just driving like 9. That's the main.
Oh, you went too far into it. You kind of wrote
I literally went off of his sentence. I went off of his sentence.
Another day anyway.
I mean, like,
Yeah, that's pretty nice. I'm trying to be good.
I have to do this all night. How can you
I don't know.
Is it in the book?
Yeah, no, it's in the book.
Yeah, no.
The worst one was. This wasn't bad. It was so torn.
I hate when I ask two questions.
That's one I was confused on.
Okay, let me pull up the. How do we do
It's 2 years.
So, this would be. Maybe let's talk about how did you categorize your compounds? What did you look at? So you all, the groups that did this, what did you look at? Base? Okay. Okay.
Non-metals and metals.
Non-metals and metals, okay. So you all have 3 groups, let me walk through. Okay, so there's all ways, I didn't tell you that you needed to use acids and bases. So there's a lot of different ways you could group these, okay? So based on your definition, you could have grouped them a lot of different ways, all right? I'm going to show you how you could group them based on acids and bases. So if I was going to group them based on acids and bases, this is what we would group them based on. So, oops, I didn't put it there. So the top one, those are all acids. I know they're acids because they have a hydrogen that can come off. So we kind of talked about that last time. These all have hydrogen. This is the hydrogen that's acidic, and this is acetic acid. These are all bases. Okay, these have hydroxide. This one makes more hydroxide in solution, so that's why it's a base. And then these ones don't have any hydrogens that are acidic, and they don't have any hydroxides. These are just ionic compounds. Okay. All right, so one of the LX topics is that we have to identify acids and bases. Do you have the sheet? So these are the acids and bases that you have to memorize. So now, in some of the LX problems in this chapter, it will say, we added nitric acid to something, and you have to know that. Nitric acid is HNO3, okay? Or some of the weird ones, perchloric acid is HClO4, just chloric acid, HClO3. So you are gonna have to memorize these, right? Or if you can fit them on a single-sided note card, you're gonna have to write them on your single-sided note card. There are two, so these are strong acids and strong bases. You have to know acetic acid, that's the weak acid that you have to know, which is this formula, these two formulas, or this formula. And you have to know the weak base, ammonia. We hopefully already know ammonia, but that one is a weak base. Okay, we'll talk more about what that means. All right, so let's go to the Alex topic that is most like this question. Where is it? I didn't bring it over. So the first Alex topic we're going to go over is this one. It is classify each chemical compound listed in the table below. So we are looking for, is it an acid or a base? And then we're also looking for, is it ionic or molecular? And we've been practicing this with some of the topics we've been doing. Ionic, remember, we need a metal and a non-metal, or we need ammonium. And then if it's molecular, it just has non-metals and it doesn't have ammonium. Watch out for ammonium. That was kind of Let me read over. I have a list of topics somewhere. Okay, so when I go through this, I'm going to look. The first one is sodium fluoride, NaF. Sodium is a metal. Sodium's in the first column. So if it's a metal and a non-metal, then that's ionic. Okay. This one is not an acid or a base because there's not hydrogens and there is no hydroxide, OH. So this one's not an acid or a base. Okay, the next one, H3PO4. Is this on our list? This one's not our list. This is just, it's the weak acid. We can recognize this as an acid because it has hydrogens at the beginning. So this one is going to be an acid. This one is molecular. There are no ions besides the protons, the hydrogen ions. This one doesn't have any metals. No metals, so this one's molecular. Okay, this one is this one on here? No. Okay, this one also has the hydrogens at the beginning. If it has hydrogens at the beginning, that's going to be an acid. It doesn't have any metals. This one's going to be molecular. Okay, this one has potassium at the beginning. Potassium at the beginning means it has a metal, and then that group of, this is nitrate. This group of elements has a negative charge, positive and negative charge, this is ionic. It's not an acid or a base. Okay, all right. This one is just one you have to be familiar with these. So I would just practice this one a lot and be comfortable doing that for the test, okay? Yeah, I think the biggest thing is looking for metals and then looking for hydrogens at the beginning. Let's do another one. Okay, so the first one that I have up here has hydrogen at the beginning. If it has hydrogen at the beginning, it's going to be an acid. Usually acids are molecular, but let's just check. Is there any metals? No metals, so it's molecular. Okay, next one has potassium and chloride. Potassium is on the left. Potassium is a metal. So I have a metal and a non-metal, that's ionic, an ionic compound made up of a positive potassium and a negative chlorine. This one doesn't have any hydrogens, so it can be an acid or a base. Okay, next one, MgBrO3. I think this is, I don't know. Is this one of the polyatomic ions we had to memorize? Bromate. This is magnesium bromate. We have a metal and a polyatomic ion. So we have positive magnesium, negative bromate, so this is ionic. There's no hydrogen, so it can't be an acid or a base. And then this one is H3PO3. We saw this one already. It has hydrogen at the beginning. That's an acid. It doesn't have any metals, so it's molecular. Questions so far? I haven't seen any bases. Have we seen? Let's try it one more time, see if we find any bases. Okay, great. First one's a base. This first one we have NaOH. Metal at the beginning, that's ionic. We also have OH at the end, that's a base. Okay. So the bases you have to know are if they have an OH or if it's the weak base on your paper, NH3 is a weak base. Okay, next one is H2SO3. This has a hydrogen at the beginning. It's an acid. It is molecular, no metals. Okay, next one has hydrogen at the beginning. It's an acid. It has no metals. It's molecular. Okay, last one has hydrogen at the beginning. It's an acid and no metals. It's molecular. Okay, questions on that? You think you could do that? Okay. All right. Make sure that if it is like, don't click more than 2 boxes. And then if it can be ionic and not be a acid or a base. So don't put it in that category. Okay. If it's just ionic. All right. Let's see. Let me see. What are we doing now? Okay, let's do the next one. Identifying Bronsted-Lowry acids and bases. Is that one on here? Yeah. Mine's the last topic on my options. For each chemical reaction in the table below, decide if it is a Bronsted-Lowry acid, a Bronsted-Lowry base, or neither. Let's go back to our slides and get a definition. Oh, that's the wrong thing. Where are the slides? Okay, so we have a few definitions of a Bronsted-Lowry acid or base. So a Bronsted-Lowry acid is something that can give away a hydrogen ion. That's the definition. It can give away a hydrogen. So all of these things can give away a hydrogen. This is, yeah. We abbreviate this often as HA to just show like we have something. We have chlorine, bromine, nitrate, sulfuric or sulfate, or acetate, something like that, as this other piece of the acid. And then the important part for a Bronsted-Lowry acid is this hydrogen. Okay, so that's what we're looking for. Does it give away a hydrogen? Then it's the Bronsted-Lowry acid. Give you a minute. I think people are ready. The base accepts the hydrogen. So if it starts out with the hydrogen and doesn't end up with the hydrogen, then that's the acid. It gives it away. If it accepts the hydrogen, that's the base. So that's why ammonia is a base, because it can accept hydrogens.
So if it accepts it, it's the base?
If it accepts it, it's the base. Oh, this will be important when we talk about the titration. So these are all acids, but sometimes acids have more than one hydrogen. So we'll do probably the third class period on chapter 9. We'll talk about titrations. So can you see how at the top acid has one hydrogen? That's called monoprotic. The second hydrogen, or the second acid has 2 hydrogens. That's called diprotic. The third acid up here has 3 hydrogens that it can give away. So that's going to affect how much base we add in a titration. So we'll talk about this again, but there's one topic in ALEKS that talks about di, mono, or triprotic acids. So that's what it means. It either has 1, 2, or 3 protons that it can give away. Okay, let's see. So these are Bronsted-Lowry bases. The base has to have a lone pair or an OH that can accept a hydrogen. So just like we talked about, the acid is giving away the hydrogen, the base accepts the hydrogen. So ammonia has this lone pair that it can get an H plus here. Water has 2 spots that an H plus can come in here. Any OH can accept H plus. So anytime I have any OH, okay. So these would all be considered Bronsted-Lowry bases. But when we're doing the topic that we're going to look at, we're looking at, is it going to accept the base? Did it get the hydrogen? So that's the base, or did it give the hydrogen? That's the acid. I think that's confusing. That's something that I would put on my note card because it makes me confused. I would probably put an example of this on my note card because I feel like it's easy to flip them. Okay, let's practice. Where is ALEKS? Okay, so we have this problem up here. We have HI, and we have OH, and then we end up with I and water. So first look over here. We have HI, and now we have I. So what happened here? this HI gave away the proton, right? Now it doesn't have a proton. It wants us to look at this red piece, the highlighted reactant. What happens here? Well, it had OH, and now it's H2O. So it's the base. It accepted the H+. You see that? So this is the Bronsted-Lowry base. It accepted the proton. Okay, next one. This is the same reaction. We're just looking, where did it start? Where did it end? What happened? So it started as HI. Now it has I. So it gave away the proton, the H+. So it's the acid. If it gives it away, then it's the acid. This is really, like, it should be straightforward, but like it's super easy to flip them. And so that's why I put some examples on my note card so that I can have something to compare to, so that I don't get it backwards on the test. Okay, how about this one? We have I. This reaction is now just written in reverse. This is like a reversible reaction. So we have I. What happens? Now it's HI. So it gained the H. It accepted it, so it's the base. Okay, and then water. What happens here? We started with water. Now it lost the H. So now it's acid. Oops. Okay. I don't think I've ever seen this be neither. This is just to throw you off. Don't pick neither.
If it wasn't there, would it just
It'd
stay
be
the
like,
same?
or it'd be like NaCl. Splits into Na and Cl. There's no hydrogens. No acid-base stuff going on. Okay, let's do another one. How are we doing? We're doing good. Okay. So this one up here, we have HSO4 minus. Okay, I have another hydrogen. That means it gained a hydrogen. So that means this is the base. It's acting as the base because it got the hydrogen. If it's accepting, it's the base. Okay, this one is called hydronium. It's just water with an extra proton. It goes from H3O to H2O. So it's getting rid of a hydrogen. If it's getting rid of the hydrogen, that's the acid. Okay. And next one, is this just the same thing written backwards? So just look where you start, look where you end. We gained a proton. So that means it's the base. Okay, this one, we started with H2. Now we just have one H. So from here to here, this is giving the H. So it's going to be the acid. Okay. You think you could do that? Yeah. Okay. All right. Okay. That's surprisingly confusing. So make sure you practice that one. All right. What's the next one? Okay. This one is finding the conjugate acid or base. Let's see. How do we want to do this? I have another activity. Let's see if we can go through our slides first. Okay. All right, so this is kind of important. Oh, why did it do that? So we need to know these terms. So acid, and then the acid has a conjugate base. So the thing that's left after we get rid of the proton, this hydrogen, is called the conjugate base. So an acid always has a conjugate base. A base always has a conjugate acid. So that's what we're looking in that column. So if we gain a proton, then this thing can give away the proton. So this acid-base pair, this one's the base, and this one's the acid. We could go back that way. Okay. So I have another activity. I need to make more activities. Yes. I'm gonna trade you. Will you hold up those ones? The ones you have, you already have it. And I'll trade you. So you're going to try to match the conjugate acid-base pairs. Will you guys come to this table and then you can do it just for the activity? So you're gonna try to find the ones that differ by one proton, one hydrogen ion, and match them up. Match them. So you're looking for the pair. They have to differ by a hydrogen. One's going to be the acid, one's going to be the conjugate base. And some might fit in more than one spot, so you have to kind of reasonably look at it.
Oh, you're just taking one on it?
Were they ordered? Right, yeah.
That's based on its G.
After school, go home.
That's not enough.
Because I don't remember what I was doing. I was probably up
I don't know what you're doing. Go ahead. You got it? Okay. Okay, so that's not too bad if you have both of them. Where is the, okay, so they should match. They should just be different by one. So this would be the acid, this would be the base. So we can say if this is the base, this would be the conjugate acid. If this is the acid, this would be its conjugate base. They just have to differ by one proton. Okay. You guys did that okay? Okay, you guys are, I don't know why. Maybe, I don't know. In the past, people have had a really hard time with this. Maybe I gave you more instructions. Oops. Okay, so let's do this topic. Where is it? Here it is. We're looking for finding the conjugate acid or base. The conjugate of an acid or base. Okay, so this is where it's tricky. You have to decide, okay, this is the acid. What happens with an acid? Yes, good. The acid gives one away, just one. When we give an acid away, when we give a hydrogen away, it also goes with an H+. So we also have to change the charge. If I get rid of an H here, then it's going to drop the charge by 1. Okay, so my new formula will be NH3 with no charge. Because I'm not just giving away a hydrogen, I'm giving away a hydrogen ion, H+. Does that make sense? So maybe we'll do, would it help to write out? Maybe it would help to write it out. So for the one that we just looked at, we had NH4, this is ammonium plus. If it's an acid, it's going to give away the H+. And then we have NH3 by itself. So this positive charge is going away with the hydrogen ion. Okay. The next one I think was hydronium, H3O plus. So you're getting rid of the H+, and you just have H2O now. Okay. So overall, both sides of your formula has to have the same charge. So both sides have a charge of 1, so we're good. Okay, so that's what we're doing on this problem. So this one we're going down by a charge and down by a hydrogen. Okay, this one we have 3. So what happens if I go down by a charge here? It has no charge. So I'm going down by hydrogen. Yeah, so then it has to be negative. PO.
What if it's already negative and it goes down by a charge? Would it be 2 minus?
Yes. Yep. 4. Don't change anything else, just the number of hydrogens. We dropped the charge by 1, so this would be a minus now. Okay. Conjugate acid. So base to the acid, we're going the other way. We're adding H and a plus. So our charge has to go up by 1, and we have to get a hydrogen. So we're always going to put the hydrogen at the beginning. So this one doesn't have any hydrogens. We're going to put the hydrogen at the beginning, H, and then put, oh, just one. I don't need more than one. HCO3. Okay, what's 2 minus? I added H plus, so I'm going to get just minus. Oops. Maybe I should put it as a superscript. Yes. Okay, this one is hydroxide. If I add H to it, you need to write it as H2O. Okay, you can't write HOH. So now I have 2 hydrogens. The charge went up by 1. So now we're at 0 charge. All right, and then the last one is, if I add an H plus here, then we're going to have H and then Cl and then O subscript 3. The charge went up by 1. Okay. This one's kind of tedious. You have to make sure that you have all of those subscripts in. Make sure you capitalize the element. And then just make sure you're going the right direction. Okay, do you want to do another one of these? Okay, let's do another one. Okay, going from an acid to the base, it's going to give away an H+. So we have to lose a hydrogen. So I got rid of the hydrogen that was there. And I have to go down in charge by 1. So it was at 0, minus 1 from the charge, so it's minus. Okay, this one starts with a hydrogen and a minus charge. I have to get rid of 1 hydrogen and drop the charge. So this one will be ClO3. And then this one will now have a 2 minus charge. Okay, this one gave away a hydrogen. So you have to remember when I write hydroxide, hydroxide is OH minus. So I got rid of a hydrogen, I dropped the charge. All right, next one. This is a base. To get to an acid, I have to gain a hydrogen. So this one will be NH4. And I'm gaining not just hydrogen, I'm gaining a positive charge also. NH4 plus. Okay, this one, water, when water gains a hydrogen ion, it's going to be H3O plus. Okay, last one. Going from the base to the conjugate acid, I'm gaining an H plus. So I need H and then Cl, and I raise the charge by 1. So this one is easy to just like do the problem and then go back through. Is this what plus 1 hydrogen, plus 1 hydrogen, plus 1 hydrogen? Is it plus 1 charge, plus 1 charge, plus 1 charge? Yes. Is this one minus hydrogen, minus 1 hydrogen? Yes. Is it minus 1 charge, minus 1 charge, minus 1 charge? So you can kind of run through all of them at the end. Oh no, I missed one. Minus 1 hydrogen. What did I do here? You've entered, doesn't seem a chemical formula. Did I put a 0? Which one is
It
it?
looks like a O.
If you scroll up, it'll tell you which one it is.
H, conjugate base of HCO.
It's already plus.
Oh, I put Cl. It's not Cl, it's C. Oops. The one above it was Cl. Okay, there. You see that? Okay. Did we do the rest of it right? Okay. Okay. Do you think you could do that one? Or do you want to do another one? We're good? Okay. Okay. Let me see. Where are we? So we've got through 3. Let's try one more, then we'll be filling a little bit more ahead. So let's do, maybe you can't do this one. Can you do recognizing? Is that even on here? Recognize. Look at that one. Maybe it's not in there.
Personal trash.
What's this one?
You're right.
Okay, so this one's not too bad. Let's pull up the notes. The next, I think, understanding the difference between strong and weak acids. Okay, so when we are talking about a strong, why did it do that? I'm not sure. That's annoying. When we're talking about a strong acid, so the strong acids are the ones on your sheet. Strong acids or strong bases. Those ones completely dissociate into their pieces. So if we have HCl, we're going to get all of the hydrogens are going to split off from the chlorine. The chlorine can donate all of the hydrogens to solution. Alex really likes hydronium, so we're going to use hydronium as our thing that's floating around. So hydrogen is going to be donated to water, and then we have hydronium floating around, and we have chlorine floating around. Okay. If we have a strong base, all of the sodium and the hydroxide split apart from each other. Okay. And we'll end up with water, sodium ions and hydroxide ions. So it's completely breaking apart. That's a strong acid or a strong base. If we have a weak acid or a weak base, they're only partially splitting apart. Okay. So if we have a strong acid and a strong base, then we're going to look for, in solution, we'll have our hydrogen, H+. Actually, we won't have hydrogen. We'll have hydronium. Actually, I think on this topic, Alex accepts both. So you can either put H+ or H3O+. Depending on which chemist you're talking to, they use those kind of interchangeably. Okay, and then Cl- and water. So those would be the only three things present. You will have no more HCl. Because it's a strong acid, all of those are broken apart. That's the point. No more HCl, okay? Let's see. If we have a weak acid or a weak base, then those only partially split apart. So we still have some of this original acid floating around, okay? So we get some of the conjugate base and we get some of the conjugate acid, but we still also have some of the original acid. Does that make sense? Because it's a weak acid. They're not all breaking apart. It's not as strong as the other ones. Or if we have a base, the base only partially accepts hydrogen. So only some of these will accept a hydrogen from the water. Does that make sense? Let's do this problem. I think that will make more sense. Okay, so this is what we're looking at. They have given us an acid. This is one that you need to know. Hydroiodic acid. No, it's not. Just kidding. Never mind. It's going to tell you if it's strong or weak, and then you have to decide what's going to be in solution. If it's strong, then there's only going to be three things. There's going to be hydrogen ions or hydronium ions. So let's put that. This will have H. I just like H+. That's easier for me. H+. I'm going to have the conjugate base. So H is going to split off of iO3. And I'm going to get HO3 minus. Okay, do you see where that came from? I'm just taking the acid and it's breaking into its pieces. Hydrogen and the thing that's left over. And this is in water. Oops, there's a 3. I don't know where that came from. Oh, where did my 3 go? I put a comma there? This is in water, so we also have water. Okay, does that make sense? Those are the 3 things that we're looking for. You can either put H plus or you can put H3O plus. Alex really likes H3O plus. I like H plus. Okay, next one. This is a weak acid, so we're going to have some of the original acid left over. So I'm just going to write exactly what I have right there, H2S. Okay, so not all of that is going to split apart. And then if it's weak, I'm only going to have one of the hydrogens come off. So if it's a weak acid, then I'm going to also have H plus. Oh. And I'm going to have the conjugate base, HS minus. And it's in water, so I better have water somewhere.
Is there always water?
Yes. Okay, the next one says it's weak. So if it's weak, then we're going to have some of the original acid left around. Not all of it is strong enough to break apart from each other because it's weak. Okay, then we're going to have H plus or H3O plus if you prefer. And then we're also going to have the conjugate base, NO2, whatever is left after the hydrogen leaves. Oops, it's a minus. Come on, go. Why isn't it going up there? What? Come on. Okay, I'm gonna have to click on it. And then we get water. Oh, also this works. Oops. Oh. This will work to copy paste. So you can just copy paste water.
Wait, the top is NO2. What?
Oh, I don't know what's going on there either. Thank you for
No, it's
coming.
supposed to be mine.
It should be a minus, yeah. And the last one also says it's weak. So if it's weak, I'm going to have the same thing. H. Oh my gosh, this is tedious. H2 SO3. Okay, we're going to get hydrogen ions. I guess I could copy my hydrogen ion also. And then we're also going to get the conjugate base. So we will only ever break off one of the hydrogens. So this will still have H, SO3 with a minus charge. Oh. And then water. Did I copy paste it? Okay. Let's see if we got that. Okay, so that one's also kind of tedious. I think a lot of this is like not too hard, but you have to like be super careful with all of the letters and the charges. Okay, do you want to do another one of these?
Yeah.
Okay, next one. And then I think we're gonna stop here for today. So this one is weak. If it's a weak acid, then we will have some of the original acid left because not all of it could split off. So that's the first thing that I would do is just write down, if it says it's weak, I'm going to write down the original acid. We're going to get the hydrogen ions. We're going to get the conjugate base, ClO. Oops. Oh. This splits off and becomes ClO minus. And then we're also going to get water. Is this still copy pasted? Great. One trick would be to put your proton and your water next to each other, and you could copy those to the next one, because that's probably going to show up in the next one. Okay, this one's strong. That means there is no of the original acid left. It will all break into pieces. So we're going to only have H+. We're going to have the conjugate base, BrO, 4-. Oh, why did it do that? Got rid of my 4. That's a 1. I need the minus. Oh. And then water. Okay, these are weak. So if it's weak, so if it's weak, first write the whole formula out, because some of that will still be in solution. H2SO. Not all of that will break apart because it's weak. And then we'll get H+. We'll get the conjugate base. So whatever broke off from the hydrogen, we got HSO3. Remember, we have to drop the charge. So this one's going to be negative. Oh, that's a 1. And then we also get water. Okay, and then the last one is weak. So if it's weak, first copy down the original formula, because we'll still have some of that left over. We'll have H+. We will have the conjugate base, so drop a hydrogen, drop the charge, and we will have water. Hopefully we got that all. Oh no. Your answer for the major species in water is HClO2. HClO2. Oh, I forgot the 2 O's. There's 2 oxygens. Okay, so yeah, be really careful. I've already messed up twice today, so just double check. Oh yeah, sorry. All right, do you think you could do this one now? Kind of tedious, but does it make sense? The species present. Okay. All right, we're gonna stop there. Next time we will talk about more about strong and weak acids, and we'll see kind of from there. We might also talk about, I think one of the labs we're going to do a titration, so maybe one of the next classes we can talk about that lab.